The universe has always hidden its greatest secrets in the darkest corners of existence. For centuries, humanity looked at the night sky believing the stars were permanent, fixed lights decorating an unchanging cosmos. But every time our technology improved, another illusion collapsed. We discovered that stars are born and die, galaxies collide, black holes consume entire systems, and space itself stretches across unimaginable distances. Yet every new answer led to even bigger questions. Then came a discovery that wasn't simply another mystery waiting to be solved. It was a contradiction. Nearly 12 billion light-years away from Earth, astronomers detected a distant galaxy that should not exist in the form they found it. It wasn't alarming because of its size or its distance. What terrified scientists was that this galaxy appeared to have already lived a complete life at a time when the universe itself was still incredibly young. The first clues arrived not with alarms or dramatic announcements but through streams of numbers captured by one of humanity's most advanced instruments, the James Webb Space Telescope. At first, it appeared to be just another faint smudge of light from the ancient universe. But as researchers analyzed the infrared signals more carefully, they noticed something deeply unsettling. The galaxy's light carried the signature of old stars. Young galaxies are supposed to blaze with energy, bursting with newborn stars and enormous clouds of gas collapsing under gravity to create fresh stellar nurseries. They should look chaotic, violent, and alive. Instead, this galaxy resembled a city whose lights had gone out long ago. It looked ancient, quiet, and strangely complete. Scientists immediately suspected an error. Throughout the history of astronomy, extraordinary discoveries have often turned out to be mistakes caused by faulty instruments, flawed calculations, or misleading data. So they tested everything again. Different teams reanalyzed the observations using independent methods and alternative models. Days turned into weeks, and weeks into months as researchers searched desperately for a mistake that would restore order to their understanding of the cosmos. But every analysis returned the same result. The signal was real. The galaxy was real. To understand why this shook the scientific community, we have to imagine what the early universe was supposed to be like. Shortly after the Big Bang, there were no planets, no galaxies, and no stars. The universe was a hot ocean of particles gradually cooling as it expanded. Gravity slowly pulled matter together, forming enormous clouds of hydrogen and helium that eventually collapsed into the first stars. These early stars burned fiercely and died quickly, exploding as supernovae that forged the heavier elements needed to build planets and life itself. Over vast stretches of time, galaxies emerged from this cosmic violence. According to every accepted model, young galaxies should have been turbulent construction zones filled with rapid star formation, collisions, and constant change. Maturity was supposed to take billions of years. The James Webb Space Telescope was built to witness this process. Positioned far from Earth, equipped with a massive mirror and ultra-sensitive infrared detectors, Webb became the most powerful machine ever created to study the ancient universe. Because light takes time to travel, looking deeper into space means looking further back in time. The photons Webb captures today began their journeys billions of years ago, carrying authentic records of cosmic history. But among those ancient signals came a message no one expected. This distant galaxy appeared far too old. Most of its stars seemed to have formed extraordinarily early before star formation abruptly stopped. It was as if astronomers had planted seeds in the morning and returned by afternoon to find a fully grown forest already dying. It was like discovering an abandoned city during the first week of human civilization. If these observations were correct, then this galaxy had somehow accelerated through stages of evolution that should have required far more time than the universe had available. Even more disturbing, hints of other unexpectedly mature galaxies were beginning to appear in Webb's observations. Scientists cautiously referred to the growing problem as tension between theory and observation. It was a diplomatic term, but beneath it lay a frightening possibility. Either the data was misleading humanity, or the theories that explain how the universe formed were incomplete. one of them had to be wrong. And at the center of this growing conflict stood a faint red glow from the edge of time itself, a silent ancient ghost challenging everything we thought we understood about the beginning of existence. The question was no longer whether something strange had been discovered. The real question was far more dangerous: what if the universe grew up faster than the laws of physics allow? And if that is true, what else have we misunderstood about the story of our own cosmic origins? When scientists finally accepted that the mysterious galaxy was real, an even more troubling question emerged. How had it become so old so quickly? The universe, according to everything we thought we understood, simply hadn't existed long enough for this object to reach such maturity. Astronomers immediately began searching for explanations, testing every theory capable of preserving the cosmic timeline without rewriting the laws of physics. The first possibility seemed straightforward: perhaps the galaxy had grown through a series of violent mergers. In the early universe, galaxies frequently collided and combined, transforming small structures into larger ones. Massive bursts of star formation often followed these collisions as enormous clouds of gas compressed together, creating countless new stars in relatively short periods of time. It sounded promising. Maybe this galaxy had simply been an overachiever, assembling itself through an unusually rapid sequence of mergers. But the mathematics refused to cooperate. To build a galaxy of such enormous mass through repeated collisions required time, more time than the universe had available when the light from this object began its journey toward Earth. The process demanded generations of galaxies forming, merging, stabilizing, and evolving. The cosmic clock simply moved too slowly. The first explanation collapsed under its own weight. The second theory shifted attention toward one of the most mysterious objects in existence: supermassive black holes. Nearly every large galaxy we observe today contains a giant black hole at its center, millions or even billions of times more massive than our Sun. When these black holes actively consume surrounding material, they release extraordinary amounts of energy capable of heating or ejecting the gas needed to create new stars. Astronomers call this process feedback, and it has been observed shutting down star formation in mature galaxies throughout the universe. Perhaps an unusually powerful black hole had rapidly extinguished this galaxy's ability to create stars. Mechanically, the idea made sense. The problem was timing. To influence an entire galaxy so dramatically, the black hole itself would have needed to grow at astonishing speed, reaching enormous mass while the universe was still in its infancy. Once again, the equations objected. Black holes were not supposed to mature that quickly either. The third explanation ventured into even stranger territory: dark matter. Although invisible and impossible to observe directly, dark matter is believed to make up most of the matter in the universe. It acts like an unseen framework, using gravity to guide the formation of galaxies and cosmic structures. Maybe, some researchers suggested, dark matter behaved differently in this region of space. Perhaps it clustered more efficiently, accelerated galaxy formation, or operated according to rules that break down under extreme early universe conditions. It was an intriguing possibility because dark matter remains one of science's greatest mysteries. Yet it was also frustrating because we cannot directly observe it. We can only infer its presence from the effects it has on visible matter. The evidence offered possibilities but no clear answers. Then came the explanation that many cosmologists found most unsettling of all. What if the problem wasn't the galaxy? What if the problem was our understanding of the universe itself? Modern cosmology rests upon incredibly precise measurements of cosmic expansion, the cosmic microwave background, and the evolution of large-scale structures. Together, these observations suggest the universe is approximately 13.8 billion years old and evolved according to predictable stages. But if galaxies like this one truly existed so early and in growing numbers, then either the universe evolved far faster than our models predict or some fundamental assumption hidden deep within those models is incomplete. It was a possibility few scientists welcomed because it threatened decades of work. Entire textbooks, simulations, and theories depend upon the accuracy of that cosmic timeline. Changing one piece of the puzzle could force countless others to shift as well. As more observations arrived from the James Webb Space Telescope, the sense of unease only deepened. This galaxy was no longer viewed as an isolated anomaly. Other ancient-looking galaxies appeared in regions of space where they shouldn't have existed according to accepted theory. Some still showed faint traces of star formation, while others seemed remarkably mature. Together, they hinted at a pattern rather than an exception. Scientists used cautious language, describing a growing tension between observation and theory. Yet behind closed doors, many understood the gravity of what that word implied. Tension means reality is refusing to match expectation. It means nature is revealing something humanity has not yet understood. Perhaps there are unknown processes accelerating galaxy formation. Perhaps black holes behave differently in the early universe. Perhaps dark matter hides secrets beyond our imagination. Or perhaps the timeline we have trusted for generations is missing a crucial chapter. The deeper astronomers searched for answers, the more they discovered that every explanation solved one problem only to create another. The impossible galaxy had transformed from a fascinating observation into a challenge directed at modern cosmology itself. Somewhere in the darkness of the ancient universe, hidden among stars older than they should be, reality was whispering that our story of cosmic beginnings might be incomplete. And for scientists dedicated to understanding how everything came to be, there are few discoveries more terrifying than realizing the universe may have been following rules we have yet to learn. The most disturbing discoveries in science are not the ones that reveal something new. They are the ones that expose cracks in ideas we thought were settled forever. For decades, cosmologists believed they had assembled a reliable timeline of the universe's history. The Big Bang marked the beginning. Matter cooled and gathered under gravity. The first stars ignited. Galaxies slowly formed through mergers and growth. Over billions of years, chaos evolved into structure, and structure eventually created the conditions necessary for planets, life, and conscious observers capable of looking back and understanding the process that produced them. It was an elegant story supported by mountains of evidence and refined through generations of observations. Yet the appearance of these ancient galaxies in the young universe raised a deeply uncomfortable possibility. What if the timeline itself was incomplete? What if the universe had been moving faster than we realized? To understand the magnitude of that question, imagine building a 1,000-piece puzzle using a picture printed on the box as your guide. Piece by piece, everything appears to fit perfectly until the final section reveals an image that doesn't belong there at all. Suddenly, you are faced with two possibilities. Either a few pieces have been placed incorrectly, requiring only minor adjustments, or the picture on the box was never entirely accurate to begin with. Modern cosmology now finds itself in a similar position. The universe has always been our teacher, and every observation is another lesson in humility. Time and again, humanity has learned that nature has little interest in preserving our expectations. We once believed Earth stood at the center of creation. We thought our galaxy represented the entire universe. We imagined space and time as absolute until Einstein demonstrated that both could bend and stretch. Every scientific revolution begins the same way. Reality refuses to obey the rules we assign to it. The galaxies revealed by the James Webb Space Telescope may represent another such moment. Some researchers have begun exploring whether conditions in the early universe allowed matter to collapse into stars and galaxies far more efficiently than our current simulations predict. Tiny fluctuations in density could have behaved differently under extreme circumstances. Unknown interactions between particles might have accelerated structure formation. Perhaps the first stars were vastly more massive than expected, living fast and dying young while rapidly enriching their surroundings with heavier elements needed to build future generations of stars. Even small adjustments to these processes could dramatically alter the speed at which the cosmos matured. Others wonder whether dark matter itself hides properties yet to be discovered. Although it shapes the universe through gravity, scientists still do not know what dark matter actually is. It remains invisible, detectable only through its influence on visible matter and light. If dark matter interacted with itself in ways our models fail to account for, it could have changed the pace of cosmic evolution. Entire galaxies might have assembled more rapidly than anyone anticipated. Then there are those willing to ask even more radical questions. Could our measurements of cosmic expansion contain hidden uncertainties? Have we misunderstood aspects of the universe's earliest moments? Is it possible that the equations governing the evolution of space and time require revision under extreme conditions? These ideas are controversial, not because scientists reject new possibilities, but because the evidence supporting the existing framework is extraordinarily strong. Challenging that framework means confronting decades of successful predictions and observations. It demands extraordinary proof. Yet history reminds us that extraordinary proof often arrives from unexpected places. The same universe that once forced humanity to abandon the notion of a stationary Earth may now be asking us to rethink the story of its own childhood. What makes this possibility so unsettling is not simply that we may have overlooked a detail. It is that our confidence in understanding cosmic origins may have been greater than our knowledge justified. Science thrives on uncertainty because uncertainty creates opportunity for discovery. Every unanswered question becomes an invitation to explore deeper. The impossible galaxy and others like it have transformed from distant objects into mirrors reflecting the limits of human understanding. They remind us that knowledge is never final. Every theory is a map rather than the territory itself. Maps help us navigate, but they are only useful until reality reveals roads we never knew existed. Somewhere in the darkness of the early universe, ancient stars shine with a message carried across billions of years. That message is not necessarily that everything we know is wrong. Perhaps only a few equations need refinement. Perhaps the explanation lies hidden within physics we have already discovered. But there is another possibility, one both thrilling and terrifying, that the universe is larger, stranger, and more creative than our greatest theories have imagined. If that is true, then humanity stands once again at the threshold of a scientific revolution. The story we tell about the birth of everything may still be unfinished. And beyond the edge of our current understanding, the cosmos waits patiently, holding answers to questions we have only just learned how to ask. The farther humanity looks into the universe, the more we discover that certainty is often an illusion. For thousands of years, our ancestors looked up at the stars searching for meaning, believing the heavens represented perfection and permanence. Today, armed with machines capable of seeing nearly to the beginning of time itself, we have replaced mythology with mathematics and observation. Yet even now, standing at the peak of scientific achievement, the universe continues to surprise us. The silent galaxy at the edge of cosmic history is more than a distant collection of stars. It is a reminder that discovery does not end with answers. Sometimes, the greatest discoveries begin when our answers fail. Across the coming years, some of the most powerful observatories ever built will focus their attention on this mystery. The James Webb Space Telescope will continue peering deeper into the ancient cosmos, searching for more galaxies that appear too old, too massive, and too mature for their age. The Nancy Grace Roman Space Telescope will survey enormous regions of the sky, identifying countless new candidates hidden within the darkness. Ground-based observatories equipped with advanced instruments will analyze their light, measure their properties, and attempt to reconstruct the events that shaped them. Each observation will bring us closer to understanding whether these objects are rare exceptions or evidence of a universe that evolved differently from what we imagined. If these ancient galaxies prove uncommon, science will still demand an explanation for how even one managed to exist against all expectations. But if they turn out to be widespread, the consequences could transform cosmology forever. Models of galaxy formation may require revision. Theories describing dark matter could be rewritten. Assumptions about black hole growth might be challenged. Even our understanding of how the universe measured its earliest moments could change. Future generations of students may open textbooks that tell a different story from the one taught today, just as Einstein's discoveries reshaped ideas once considered unshakable. This is not a weakness of science. It is its greatest strength. Unlike belief systems built upon certainty, science advances through correction. It grows stronger each time reality exposes an error and forces us to think more deeply. Every revolution in knowledge begins with a question that refuses to disappear. The galaxy that should not exist has become one of those questions. Somewhere almost 12 billion light-years away, ancient stars continue their silent journey through space, carrying a message written long before Earth formed beneath our feet. Those stars do not care about our theories or expectations. They simply exist. Their light crossed unimaginable distances and survived billions of years to reach a species intelligent enough to recognize that something does not fit. Perhaps the explanation will ultimately be simple. Perhaps hidden within equations we already possess lies the answer that resolves this cosmic contradiction. But perhaps the truth is stranger than we dare imagine. Maybe the first billion years of the universe unfolded according to rules we have not yet discovered. Maybe creation was faster, more chaotic, and more inventive than our simulations predict. Maybe the beginning of everything still contains chapters humanity has never read. There is a profound beauty in that uncertainty. We often think of knowledge as the elimination of mystery, but mystery is what drives exploration. The desire to understand is what carried humans across oceans, pushed them beyond Earth's atmosphere, and inspired us to build machines capable of looking into the distant past. Every unanswered question is an invitation to continue the journey. And perhaps that is the true significance of this silent galaxy. It reminds us that despite all our achievements, we remain students of a universe vast beyond comprehension. We have mapped planets, measured the age of stars, and traced the afterglow of the Big Bang itself, yet the cosmos still possesses the power to humble us with a single unexpected observation. Somewhere in the deep darkness of the ancient universe, a quiet red galaxy waits without explanation. Its stars are older than they should be. Its existence challenges the timeline we trusted. It stands at the boundary between what humanity knows and what it has yet to discover. One day, we may finally understand why it formed so quickly and why it entered silence while the universe around it was still bursting with creation. Until then, it remains what all great mysteries ultimately become, a question carved into the edge of human knowledge, urging us forward. Because the most unsettling truth about the cosmos is not that it is enormous, cold, or indifferent. It is that every time we believe we have reached the end of understanding, the universe whispers that we have only just begun. And somewhere, beyond the reach of certainty and deep within the first dawn of existence, the answer is still waiting for us to find it.